Hello everyone, welcome to our channel Everyday E-Learning. In today's video, we are going to study multiplexer. So let us begin. A multiplexer is known generally as a data selector. So what it does is, if we are given a set of inputs, it can select from the set of inputs and direct it to a particular output. Here it has like a selector, and with the help of the selector it can choose any particular input, and there is a selector line below this one. So if we want to give a formal definition to it, it will be a digital multiplexer is of course a combinational circuit, and it selects binary information from one or many input lines and directs it to a single output line, as you can see in this picture. So if we take another multiplexer, for example, and with that example we are going to carry on our today's video. For example, we are taking a 4:1 multiplexer. So you see the 4:1 multiplexer here. If you might wonder, a multiplexer is also known as a mux. A 4:1 mux will have 4 input lines and single output line, as we all know, and 2 selector lines. And this is the least significant line, and this is the most significant one. Now, if you might wonder why there is one selector line and why there are 2, this is dependent, of course, on a formula, but there is obviously a shortcut to know it. Like if we have a 2:1 mux, then there will be one selector line. If we have 4:1, then there will be 2 selector lines. In this way, for 8:1 there will be 3, 16:1 4, 32:1 5, and carried on in this way. Now this is a shortcut to be remembered, but of course it depends on a formula, and the formula for that is equals to n equals to 2 to the power m, and this is the number of selector lines, and n here indicates the number of inputs. So with the help of this shortcut, you can remember how many selector lines what kind of mux will have. Now we'll draw a truth table for this mux, and then consecutively from the truth table we'll derive the logic equation, and then we will draw the logic diagram for this one. Now if we draw the truth table for this mux, we'll have enable, then selector 1, selector 0, and then output. Now when the multiplexer is disabled, we have the value of enable as 0, and then there will be no selector lines activated and the output will stay 1. Now when the enable is changed to 1, that is the multiplexer is enabled, we will have the following set of inputs for 2-bit. First one is 0 0, 0 1, 1 0, and 1 1. Now whenever the selector lines are 0 0, then we'll have I0 as our output. For the second one we'll have I1, I2, and then I3. So these are the ways how the output will be selected. Now if we want to write the equation for the truth table, we can write it as follows. So output y is equal to, we can follow the truth table here. At first we have E into this one will be S1 naught, S0 naught, and I0. Then we have plus, as we are doing it in sum of products format. Then for this one we have E, S1 naught, S0, and I1. Then we have for this one E, S1, S0 naught, and I2. And finally the last one we have E, S1, S0, and I3. So we have the logic equation. Now we can pretty easily draw the logic diagram from it. Now we see for the logic diagram we need here at first S1, S0, we need the enable, and we need I0, I1, I2 and I3. Alright, now we will also need the opposites. Let me take it a bit above for our comfort. S1 naught, and we'll also need S0 naught, and now we can easily draw the logic diagrams. So for the first one we have E S1 naught, S0 naught, S1 naught, S0 naught, and we have I and enable connected with the help of an AND gate. For the second, this one is done. For the second one we have E continued, we have S1 naught, we have S0, and we'll have I1 alone connected with the help of an AND gate. Now for the third one we have E, then S1, E comes down, then we have S1, then we have S0 naught, then we have I2 again connected with the help of AND gate, and finally we have this one, I3 will come, of course. We have enable, we have S1, and we have S0 connected together with the help of AND gate. Now all of these are connected to an OR gate, and this is our output Y. So this is the logic diagram for our 4:1 mux. In this way, the other mux, for example 16:1, 8:1, 32:1 can be drawn. In the next video we will learn some of the concepts of cascaded multiplexers. We'll also learn about quadruple multiplexers, and we'll also learn a Boolean function implementation using mux. So till then, if you have any question or comment, feel free to write it down. Thank you very much for watching this video. See you in the next one.